Hello everyone, myself Dr. Atul Saire. Today we are going to discuss about theory of infrared spectroscopy in this presentation. The contents of this presentation are 1. IR in absorption process. 2. Molecular vibrations. Learning objectives of this topic. After the end of this course, the student will be able to 1. Analyze what happens to a compound when it absorbs infrared radiation. 2. Interpret the IR spectra. 3. Identify the structure of a unknown organic compound. Now let's discuss about the process of the infrared spectroscopy. As with other types of energy absorption, molecules are excited to a higher energy state when they absorb infrared radiation. The absorption of infrared radiation is, like other absorption process, a quantized process. A molecule absorbs only selected frequencies of infrared radiation. The absorption of infrared radiation corresponds to energy changes on the order of 8 to 40 kilojoule per mole. Radiation in this energy range corresponds to the range encompassing the stretching and bending vibrational frequencies of the bonds in most covalent molecules. In the absorption process, those frequencies of infrared radiation that match the natural vibrational frequencies of the molecule in question are absorbed, and the energy absorbed serve to increase the amplitude of vibrational motion of the bonds in the molecule. Here you can see that this is a diatomic molecule, and here the covalent bond behave as a spring, and whenever the two atoms come close together or they go away from each other, the stretching of the covalent bond takes place. Whenever the stretching of the covalent bond takes place, it generates a varying electromagnetic field. However, note that all bonds in a molecule are capable of absorbing infrared energy, even if the frequency of the radiation exactly matches that of the bond motion. Only those bonds that have dipole moment that changes as a function of time are capable of absorbing radiation. Symmetric bonds such as hydrogen or chlorine do not absorb infrared radiation. A bond must present an electrical dipole that is changing at the same frequency as the incoming radiation for energy to be transferred. The changing electrical dipole of the bond can then couple with the changing electromagnetic field of the incoming radiation. Thus, a symmetric bond that has identical or nearly identical groups on each end will not absorb in the infrared. For this purpose of an organic chemist, the bonds most likely to be affected by this restraint are those of symmetric and pseudosymmetric alkenes and alkynes. Now, once you have understood the process of the IR absorption, I would like to ask you one question. What is the wavelength of the IR radiation? Now, once you are done with the absorption of IR radiation, let's move to the another important topic in the infrared spectroscopy, and that is the types of molecular vibrations, also called as modes of vibration. The simplest types of modes of vibration in a molecule that are infrared active, that is, those give rise to absorption, are stretching and bending vibrational modes. However, other more complex types of stretching and bending are also active. The following illustration of the normal modes of vibration for a methylene group introduce several terms. In general, symmetric stretching vibrations occur at higher frequencies than symmetric stretching vibrations. Also, stretching vibrations occur at higher frequencies than bending vibrations. The terms scissoring, rocking, wagging, and twisting are commonly used in the literature to describe the origin of infrared bands. In this particular animation, you can easily understand the different types of the stretching and the bending types of vibration in a molecule. So, in a methylene molecule, whenever the two CH bond they vibrate in the same direction at the same time, it is called as the stretching vibration. On the other hand, when the two CH bond they stretch in different direction at a given time, it is called as the asymmetric stretching vibration. On the other hand, whenever the bond they bend in plane, they show the two types of bending vibration, that is scissoring. One is called as the scissoring, the other is called as the rocking. On the other hand, a particular bond also can bend out of plane, and there are two types of the out of plane bending vibration, twisting and the wagging. Hope you understood the concept of the IR absorption process as well as the types of the different vibrational motion in a molecule. Thank you very much.